I wish they'd leave that music on. I'm just kind of getting my groove going here. Hey! All right. Oh, Dana. Okay, last presentation of the day. The one, the only. Well, we've got Kathy. You're going to be back up here again. And Ted. And they're going to give us an update.
Our excellent adventure.
Oh, I like the way you're going with it. All right. So please welcome IBM.
Hey, thanks.
Hey-o.
Okay. I'm Kathy Lair with IBM.
I'm Ted Latofsky with IBM.
We're going to tag team this, and one thing I have 2 lessons learned. One, don't try to do a video unprepared, because it didn't work last time. And from our session at 1:30, I talked way too long, so we don't have that much time, so my part will be really short. So, thanks for coming, and we'll start it off. So, you know, technology has created another conduit to the customer, and mobile devices coupled with the new applications are driving new workload, drastically altered the IT infrastructure. So data, as we all know, is being created at unprecedented rates, and much of it's unstructured. These are probably no surprise to anybody. Okay, Ted. You got the clicker. So improving the data analytics is essential, and what we look at as IBM are what we have today in systems of record. That's kind of your traditional environment, your traditional, actually oftentimes silos of information. And then you move towards a system of engagement, which really are the new workloads. And guess what? A lot of the budget and support within the business are in these new workloads. You need to be able to reach your constituents, your customers, your internal and external customers real time. That requires massive scale. It requires rapid pace and relying on data elasticity. So here's just another example of some of these workloads, your mobile, your social, your cloud, your big data analytics. You know, we're going to dynamic services. We're going to a lot of cloud-based services, unstructured data in motion, unpredictable workloads, and a variety of devices. So it really now comes to IT's job to how to reconcile your systems of engagement and your original systems of record. Okay. Did I do this one or did you do this one?
I'll take it.
Okay.
Okay, so what we talked about just for a moment was that we're starting to see this big trend from what we call systems of record, old static environments, to these new dynamic systems of engagement. The issue is, historically, when we deploy net new systems of record, what happens? Well, every time we deploy such a thing, we end up with net new infrastructure, usually in its own silo. New servers, new networking, new storage, and very often, new headcount. The problem with that is that you can see here is that it becomes very inefficient. In the same way that we recognize that server virtualization is a way to drive up utilization effectively in a cost-savings fashion, IBM believes that software-defined infrastructure is a way to focus on not having silos that are standalone, that require individual autonomous hardware infrastructures. How do we do that? First, we look at physical infrastructure as a shared service. Depending on what kind of infrastructure we're talking about, we often find that we have the ability to accelerate workloads often as much as 100 times. What kind of workloads? We recognize that historically, your old systems of record were regularly consolidated, corporate-owned, they were private infrastructure. And now we're looking at more and more open source, more and more open standards environments. And those open standards environments have to be extensible. Our infrastructure has to share that extensibility. We also now have to think about the fact that where once upon a time, the only reason people really cared about the cloud was because cloud was merely a delivery service. Now we regularly see that cloud is actually where work lives, not just where services live, but actual data sets and workloads live in the cloud. Finally, we also recognize that in moving around data, we may also end up moving around workload. Being able to dynamically scale and move that workload also leads to dramatic increases in performance. So now, what does IBM think about a software-defined infrastructure? First things first, we think that it should, of course, be software-defined. What does that mean to you? It means rather than having headcount spending a lot of time dynamically responding to the needs of the business, focused on things like storage deployments, server deployments. Now we want you to be thinking about things that are policy-driven, some intelligence in the environment so that you can actually automate and template your workflow. We think that the hardware for that infrastructure ought to be optimized to satisfy that. It should be scalable, it should be performant, it should be easily managed with a control plane and a data plane. And finally, we think that it should be tremendously scalable. Very often, even in best-of-breed solutions, we regularly see that there were limits to the way those infrastructures scaled. So very often, even if you were thinking ahead and trying to come up with broad-stroked, broad-brushed environments, you'd often still reach a point where when you saturated that environment, you had to deploy another one. IBM thinks that those environments now should be designed and developed from the ground up, meant to be scalable. IBM has heard the message from our customer base loudly and clearly. In order to do what we call a software-defined infrastructure, we need software-defined storage. And one of the big issues that has historically occurred is that IBM has had customers telling us that different parts of their infrastructure did not always work together. We want you to know that IBM has spent a tremendous investment, over $1 billion, not on net new development for net new features, but rather features designed to increase the interoperability and intelligence of the various parts of the portfolio. So your storage understands your backup environment, your network understands your file systems, the whole 9 yards. So Spectrum Accelerate, designed to be storage that is cloud-friendly, cloud-deployable from the ground up. Scale, meant to be massively scalable, both vertically and horizontally, capacity as well as performance for network-attached storage. Control. In order for you to do these policies, these templates, this intelligence, you're obviously going to need a control layer where you can do metrics and monitoring and instruction. Governance, what we would think of as data protection, the reporting and the metrics that go along with it. Virtualize, in the same way that obviously we've reached that point where now server virtualization is a common sense no-brainer. Everybody does it every day. IBM would tell you that we think that storage should also be virtualized. And finally, data placement, Spectrum Archive, which is a resurgence of the old original idea of HSM, right placing our data at the right time. So we now with Spectrum Archive actually have the ability to move data from tier to tier, including using tape as a nearline tier that is still readily accessible even to the end users without necessarily having to involve a storage or backup team to retrieve it.
If I could just comment here too on the Spectrum Accelerate does not require IBM hardware. And in fact, that's kind of the beauty of the software-defined infrastructure, right, is reuse what you have. We'd love to have you have all IBM, but we know that's not realistic. So I want to make sure that I included that.
So the IBM message behind software-defined infrastructure and software-defined storage. Proven technologies, we have over 50,000 unique installs, different customer base, involving all of our storage products that dovetail into software-defined. Flexible choices for cloud, appliance, and even as software running on your own infrastructure. We believe, again, that that infrastructure ought to be able to take advantage of your pre-existing infrastructure and your systems of record, as well as these new next-generation environments and systems of engagement. Finally, we have a comprehensive family of offerings meant to handle any and all of those compliancy outcomes. So, this afternoon, we especially want to talk to you about Flash Systems. A lot of vendors have varying flash technologies out there on the market. A quick compare and contrast. The IBM solution does not emulate hard drive in the sense that we're not using SSDs, we're using built from the ground up, ultra low latency, ultra high performance hardware flash. Again, we talked about data plane and control plane. Our solution specifically is all done in ASICs. So rather than actually seeing increased latency by having all of the intelligence for data motion, data placement done inside the software core, it's all being done directly in ASICs. And finally, advanced data protection, because not only can we do RAID protection across our flash modules, but all the way down to the sub-module inside the chip level, we have a variable stripe RAID technology that allows us, when a chip fails, to instead of failing the entire module, we literally have the ability to simply dynamically re-RAID all of the information on a given module, causing it again to stay up longer and work faster.
No software in the data plane is speed, essentially.
So when we talk about performance and we talk about flash, we want to talk to you about what that really means. So regular enterprise storage environments regularly move data at about the 5 to 10 millisecond time frame. When we talk about flash, we regularly talk about response times not in milliseconds, but in microseconds. We think that that's a real value as a business outcome because, by and large, in your work environment, although network has evolved dramatically, servers evolved dramatically, one of the places where we see historically that infrastructure has not kept pace is storage. We think flash answers that. So the basic building block is the IBM Flash Systems 900, and without drilling into it a great deal, we'll tell you that that module, that block, can be deployed in environments as small as 2 terabytes and as large as 57 terabytes. That's 2U and over 1 million IOPS. I think that any of the people in your environment that are storage people by trade will tell you that that's a big deal and a game changer, because historically, in order to see those kinds of performance environments, we generally needed to see 2, 3, maybe even 4 racks of storage in order to get that performance. Now, we can offer you that kind of IOP count in 2U and about 600 watts of power.
Your hairdryer.
1/3 of a hairdryer. I care about that. So, we marry that with the Flash System V9000 to a front-end storage virtualization. That front-end storage virtualization layer provides us a feature and function set that is completely enterprise ready. That environment becomes scalable all the way up to 2.5 million IOPS, and physically scalable all the way up to 456T, give or take, and can create 2.28 petabyte usable environments. So rather than just throwing performance numbers at you, I want to actually talk about business outcomes for a second. Is anybody in the audience a SQL DBA or an Oracle DBA? I guarantee you, if you run a performance report in your back-end environment, you'll see that you generally wait for disk about 2/3 to 3/4 of the time. That's industry-wide. That leads you, when you need more and more increasing loads of work in these analytics-rich environments where we're trying to respond in real time, it leads you to end up increasingly parallelizing your workflow. More and more servers trying to get the work done in the fervent hope that they can catch back up somehow, when the real problem is you're waiting on back-end storage. So as opposed to that 4 or 5 millisecond time frame, we can regularly get response times all the way down to 200 microseconds, which is obviously 20 times faster. Why do you care? Because that's going to end up reducing infrastructure costs both in storage and in server, as well as improving response time in your analytics environment, your database environments, all the way across all the enterprise applications that you're using in these net new systems of engagement. So IBM wants you to understand that you can start with small data center, single application, single program building blocks. You can use them across a set of applications to improve performance. We can involve this in multiple and mixed workloads, private and public cloud, and IBM wants you to understand that we believe in this particular solution that now Flash Systems might be a viable option for you, a cost-effective and performant option for you to run your data center. IBM is all in on Flash. IBM has been working with Texas Memory Systems since the acquisition for over 2 years, and Texas Memory Systems was a key player in the industry for the last 25 years. To that end, we are willing to provide both IOP and megabyte a second performance guarantees. Our feature set, including compression, makes it possible to store ever-increasing amounts of data on that same physical footprint. And we're committed to being able to support that infrastructure, including warranties and maintenance for at least 7 years. So, business examples. We regularly see in commodities trading and brokerage houses that we often see as much as 40 times the improvement. A key example of that is a large, privately held, largest in the world, privately held commodities for agriculture used to do database analytics against their environment in 15 hours. That became a problem because now it was eating into their production workday. Now, on IBM's Flash Systems, we see that workload happening in 52 minutes. That makes it possible for them to do daily and more than daily the kind of analytics that they actually used to have to do in batch jobs. And transactional workloads, large web transaction, large sales, online commodities, we regularly see application accelerated more than 100 times. In big data and analytics, knowing that we have the ability to not only move the data itself onto Flash, but the ability to migrate workloads where they need to be onto high-performance computing environments at the same time, we often see a 2.5 to 1 or greater improvement in our reduction in response time for analytics jobs. Questions? Comments? Please. Come on, you're making it too easy. Bueller?
So what are the expansion options? Say you start out with a 9,000, how large can it grow? What's the way of expanding it if you want to?
So the question for Matt up in the front row is, how do we expand, or what are the expansion options for this environment? So as I said, we can deploy these as small as 2 terabytes at the ground up. We can scale one in increments, so a full chassis can be as small as 11 terabytes or as large as about 57 terabytes. And a single pair of virtualization heads can control about 5 chassis. We can scale out to 4 pairs or 8 virtualization heads. And so we can scale out both vertically and horizontally in those increments, whether that's an 11 terabyte increment, a 57 terabyte increment, 1 head, 2 heads, 4 heads. Which means that we not only scale out in terms of capacity, we scale out in terms of performance as well. Thank you. Questions? Comments? Queries? Posers? Please.
Yeah, just, I love the fact that you do that extra RAID level at the chip level. And when one of those chips fails, you obviously have to have some kind of an indication that it has failed, so you do have the opportunity at some point to replace the unit. How does that work? What does that look like?
All right, so the question was, yes, we have the ability to have multiple kinds of redundancy, both in a single in a single Flash module and inside the module. How does that redundancy get reported back up, and what would a replacement look like? So first things first, inside the system itself, there's a tremendous amount of logging, much of it informational in nature. If there's a kind of chip failure that doesn't affect the integrity of the module as a whole, then you get some automated logging and notification that tells you what's going on, but all of that redistribution and rebalancing, that's still happening inside the single module. So that's simply informative, and all that work gets done, period. Obviously, if you saw a dramatic increase in the number of chips that failed, that would probably trigger a different threshold, which would make you want to replace the module, at which point you have some choices because you can proactively fail one as well. Now, if a module as a whole fails, please remember that there is RAID across all of the modules as well. In that environment, the module fails, and much like a hard drive replacement, the module is removed from service. By and large, we tend to deploy them with a spare for capacity, which means once the module's failed in the first place, whether it's done after the fact or whether it's done proactively, all the data is already going to be redistributed across the other module, at which point inserting a new module, that module becomes the spare. Thank you.
Can you talk about AWR and how we analyze workload?
So Kathy wants me to talk to you for just a moment about the idea that a lot of you will wonder whether or not you're an appropriate fit for a tier 0 ultra-high performance storage environment. IBM would tell you that there are ways to analyze all of those workloads, whether that workload is Oracle or SQL or DB2 or web backend traffic. A really good example of that is Oracle has a report called an AWR report. So as an example, I and a tremendous number of people on my team are trained in looking at AWR reports. While I don't claim to be an Oracle DBA by any means, I can tell you just from looking at your AWR report whether or not a deeper analysis should be done and whether or not your AWR report is going to reflect your disk wait time. Again, that's a very good example that AWR reports will often show people are waiting for storage between 65 and 80% of the time. You'll see something similar if Microsoft Shop. You can tell if you're looking in Perfmon, you'll be able to see whether or not you have an outstanding queue that's regularly greater than, say, 2. And anytime we see that those queue depths increase and we have outstanding, that's a strong indicator, of course, that the backend or that you're waiting on backend storage. Thank you. Any other questions? Come on, you guys are making my life too easy. We should get this guy to dance.
That's always an option.
I'll do one more.
One more, please.
If a customer wants to do say a pilot on their own individual database environment, is there a way that they can, that I can bring them a test flash system so they can put it in their environment and run it just to see on their exact network?
Yes, so the question goes like this. Let's say that a customer is interested in this, but would like to do a test, a beta test, or a try and buy, or whatever you want to call it, in their environment. There are two entirely different ways to do that. So I'm one of the people that you need to talk to if you actually want to do that. The first way to do that is if the environment is mirrorable, i.e. you have Unix accounts or Unix hosts or Linux hosts that are doing LVM, we can insert that storage directly into their environment and then do mirrors. I think I can do essentially the same thing in Microsoft with dynamic mirrors. Sometimes that's a sketchier conversation. I don't claim to be an expert in Microsoft anymore. I also have the ability, particularly if we're talking about the V9000 as a whole, I have the ability to actually insert this Flash 9000 in band, represent storage directly to it, and use the virtualization engine to do dynamic mirroring in real time after the fact, behind the scenes. The storage environment sees one change in pathing where now instead of the original storage, the original data set, going directly to the server, now it can go through the V9000. It makes it very, very easy for us to insert ourselves into that environment or to do preferred mirrors. And I'd like to think that one of the things that makes IBM a little different than some of our competitors is we can use exactly the same technology to remove ourselves from the environment. So it is both logically and physically pretty easy to both insert Flash into a working environment to see what kind of performance you get, and if you want to remove it from that environment as well. Thank you, Matt.
Can you just, I know we're about out of time here, but can you just tick through, and we don't have time to go through each one, but some of the tool set that comes with the V9000, the SVC,
Sure.
the compression,
So because the V9000 is based against the Flash 900 backend and the IBM Storewise virtualized front end, we have the ability to do mirroring, replication, flash copy, snapshots, industry snapshots, as well as the ability to we actually call the term we talked about image mode. I can do imports and exports of storage. I can use the system to do just that. I also have the ability to do compression. So depending on your data set, we often see as much as a 5-to-1 compression ratio. Obviously, there are tools for that. I'm one of those people that you would talk to about that as well.
An easy tier?
And easy tiering. Well, in a V9000, we do less easy tier. It is possible. So Kathy brings up a question. She's asking about an IBM function called easy tier. If you are going to add other storage, remembering that we talked earlier that these V9000s can be connected to your existing storage infrastructure. We have the ability to use the flash as an extension of the original storage, which allows you to get your original storage to act as if it is significantly faster than it is. Most of the time, customers notice that less than 10% of their physical disk is being regularly accessed at a very highly performant rate. IBM calls this model for moving data around dynamically easy tier, and it is an included at no additional charge feature in that environment. Thank you.
Wow, thank you very much. And both of these two will be in the vendor lounge next door for additional technical questions. And Matt, you know too much about this stuff already, so you should probably go have a drink already. Okay, that's it. We are done. The vendor lounge will be open. Make sure you hurry up if you have not got your business cards registered at each of the tables, because we'll be doing prizes very, very, very soon next door. Thank you for attending, and we hope to talk to you next door. Thank you.